E, also known as Euler's number, is a mathematical constant that is approximately equal to this number. Mathematical constants are numbers that are interesting in some way and can be applied to many principles of math. For example, pi, which is widely used throughout all of math to explain a multitude of shapes and graphs. E is used in reference to exponentials and is often called the exponential growth constant. In order to better understand E, we must first understand what exponentials mean and why E is equal to 2.71828. A situation of exponential growth involves an increase in a value at an increasing rate. For example, when looking at the population of an area, it seems to increase exponentially as long as there is space and food. In 1 year, a population of 50 may increase to 500, while in the next it may increase to 5,000. It can also be used to describe many different exponential situations, such as compounding interest.
Compounding interest is a key part of E. E was discovered in 1683 by Jacob Bernoulli while studying compound interest. If a bank account starts with $100 and pays 100% interest each year and gets compounded annually, after 1 year, that 100 will have turned into 200. This value can be found in the following expression: $100 times 1 plus 1 over n to the power of n. Starting with $100 again, if it was compounded semi-annually by 50% each 6 months, after 6 months the $100 will have turned into $150, and the second half of the year, that $150 will have turned into $225. That is given by this expression here, $100 times 1 plus 1/2 squared. This trend of compounding more and more times within a year results in a greater value each time. Compounding monthly, given the following expression, will result in $261.3. Compounding weekly results in this expression and results in $269.26. Compounding daily gives the following expression and results in an even higher sum of $271.46. What if you could make even more money? What if you can compound an infinite amount of times within a year? This following expression shows what $100 times 1 plus 1 over infinity to the power of infinity results in the amount 271.82. This amount also equals E times 100, which was the starting value. This shows that the same can be accomplished for any starting value other than 100, such as $1, $1,000, or even $1 million, as long as the expression is followed and the money is compounded continuously as a result of E times the starting amount.
When looking at such exponential situations, the mathematical constant E is used. The value of E can be described as the sum of the infinite series of 1 over n factorial.
This is given by the series of terms below, with terms of 1, 1 over 1 factorial, 1 over 2 factorial, 1 over 3 factorial, and so on. As an infinite amount of terms is added, the number nears E. When E is raised to the power of x, this can be shown by the very similar Taylor series of x over n factorial, with the following terms: 1, x squared over 2 factorial, and x cubed over 3 factorial, and so on.
Another important aspect of E is the natural exponential function, f of x equals e to the power of x. This function is the unique exponential function of type a to the x equal to its own derivative. So this means E can be defined as the unique positive number a such that the graph of the function y equals a to the x has unit slope at x equals 0. Another interesting aspect of e to the x is that the natural logarithm is the inverse function to the natural exponential function. As well, taking the natural log of e results in the answer of 1.
Hopefully you learned something new and useful about E. Thank you for watching.